All right, let's get into it. Today, we're tackling one of the biggest, most mind-boggling mysteries in all of science, the strange case of the missing universe. It turns out, when we look out into the cosmos, most of it, well, it's missing. Or maybe more accurately, we just can't see it. So what is all this invisible stuff? And how do we even know it's there in the first place? So take a look at this. According to our best science, this is basically the recipe for the entire universe. And you see that tiny little slice, the 5%? That's everything we know. Everything we've ever seen or touched, every star, every planet, every galaxy, you, me, everything. It's all crammed into that little sliver of what we call ordinary matter. Which, leads to a pretty big question. What on earth is the other 95%? Now that giant 68% chunk of dark energy, that's a whole other kind of worms for another day. We're going to focus on that other mysterious slice, the 27% of the universe we call dark matter. And this is a true cosmic detective story. Okay, so you're probably thinking, if we can't see it, if we can't touch it, how do we know it's there? Well, the answer is gravity. We can't see the culprit directly, but we can see the footprints it leaves all over the cosmos. So our first big break in the case came back in the 1970s, and it's all thanks to the incredible work of astronomer Vera Rubin. She was looking at how spiral galaxies spin, and she found something that just didn't make any sense. Okay, so on the left is what physics tells us should happen, right? Think of our solar system. The outer planets move way slower than the inner ones. Same should go for galaxies. But on the right, that's what Vera Rubin actually saw. The stars on the edge are moving just as fast as the ones in the center. I mean, they're moving so ridiculously fast that the galaxy should be flying apart, just tearing itself to shreds. So what's holding it together? The only explanation is that there must be this massive, invisible halo of matter surrounding the galaxy, holding it all together with its gravity. And the evidence doesn't stop there. Our next clue comes from one of Einstein's most brilliant predictions. He figured out that really massive objects don't just pull on things, they actually warp and bend the fabric of space and time itself. And that warp can bend the path of light, which creates something we call gravitational lensing. So what does this mean for us? Well, it's like having a giant cosmic scale. We can look at light from super distant galaxies, and by measuring how it gets distorted and bent on its way to us, we can actually map out where all the mass is in the universe, whether we can see it or not. And guess what? These maps consistently show these huge clumps of mass where there's almost no visible matter at all. And if you want the smoking gun, look no further than the bullet cluster. This thing is amazing. It's the aftermath of two huge galaxy clusters that smashed into each other. All the normal matter, the hot gas you see in pink, it collided, slowed down, and got stuck in the middle. But the lensing map, shown in blue, tells us where most of the mass actually is. And it just sailed right on through, like two ghosts passing through each other. This is it. This is the proof that this invisible stuff is fundamentally different from the stuff we're made of. Okay, so the evidence is piling up, right? Something massive and invisible is running the show out there. So, the next job for our cosmic detectives is to line up the usual suspects. Let's see who the leading candidates are. Now, the first thing you might think is, hey, maybe it's just normal stuff that's, well, dark. Things like rogue planets, cold gas, maybe a bunch of black holes. Astronomers have a great name for these. MACHOs, for massive compact halo objects. But yeah, we've pretty much ruled this one out. And that idea just doesn't hold water, for two big reasons. First, our theories about the Big Bang are incredibly precise. They predict exactly how much normal matter, what physicists call baryonic matter, should have been created. And that number? It perfectly matches the 5% we see. There's just no room for more. And second, we've looked. Scientists have done massive surveys searching for these MHECHOs, and they just don't find enough of them to explain the missing mass. The answer has to be something else, something more exotic.
All right, this is where it gets really interesting. Let's look at the suspect lineup. For decades, the prime suspect was the WIMP, the weakly interacting massive particle. Sounds good, right? But after years and years of searching in these super deep underground labs and finding nothing, confidence is kind of fading. Then you had another candidate, the Axion. These are a totally different kind of particle, super light and incredibly hard to detect. And finally, you have the real wild card idea. What if there is no particle? What if our understanding of gravity is just wrong on cosmic scales? It's a fascinating thought, but this idea has a really hard time explaining stuff like the bullet cluster.
So we've got our clues, we've got our suspects. Now the hunt is on.
I mean, literally thousands of scientists all over the globe are in this massive race to finally unmask dark matter, and they're using this really clever three-pronged attack.
First up is direct detection. This is like setting a trap. Scientists build these unbelievably sensitive detectors deep, deep underground to shield them from any other particles. And they just wait, hoping for that 1 in a billion chance that a dark matter particle flies through and bumps into one of their atoms. Then there's indirect detection. This is like looking for the wreckage. The idea is if two dark matter particles smash into each other, they should annihilate and release a burst of energy, like gamma rays. So we point our telescopes at places where there should be a lot of dark matter and look for those flashes. And third, if you can't find it, try to make it. At places like the Large Hadron Collider, we smash protons together at insane speeds, hoping we can create dark matter particles right here in the lab.
So, this is one of the most exciting hunts in all of science. But why? Why spend all this time and money looking for a ghost particle? Well, because the answer, it turns out, might just tell us everything about why we're here at all. This quote, honestly, says it all. Gravitational scaffolding. Dark matter isn't just some leftover junk floating around. It's the architect of the entire universe. It is the invisible framework that everything we see was built on.
Think about it like this. Right after the Big Bang, everything was a hot, chaotic mess. Normal matter was too hot and zipping around too fast to clump together and form anything. But dark matter doesn't care about light or heat, so it could start clumping together right away. It formed these massive, invisible gravity wells that acted like seeds. Then, all the normal gas and dust got pulled into these wells, and that's what allowed galaxies and stars and planets to form. Without that head start from dark matter, we probably wouldn't be here. It's that important. So what you should really take away from this is that finding dark matter isn't just about bagging a new particle for the textbooks. It's about understanding the very foundation of our cosmic home, where it all came from, how it was put together, and maybe even where it's all going.
And that leaves us with this huge, incredible question to think about. Is 85% of all the stuff in our universe some brand new particle we haven't discovered yet? Or is this whole mystery a giant signpost telling us that one of our most fundamental theories of the universe needs a complete rewrite? Either way you slice it, the answer is going to change everything we think we know.